Howdy folks, we are going to continue with our conversation about exponential relationships, and you've already at this point learned the basic formulas of exponential growth and exponential decay, both discrete and continuous. And what we're going to do today is we're going to talk about how to manipulate exponential expressions algebraically. Okay? And here's what you need to learn about. You need to learn about what are called logarithms. Now you may have heard logarithms. Okay, you may have heard of logarithms, you may have even worked with them before, maybe this is just a review for you. But you have to understand what a logarithm is. Now, in order to understand a logarithm, you have to understand basic exponential relationships. For example, let's say that we know that 5 to the third power is equal to 125. Okay, so 5 times 5 times 5 is equal to 125. If you understand this, if you get this, then you can definitely understand logarithms. Logarithms are basically just another way of expressing this relationship. See, we have 3 parts to this relationship. We have the exponential base, okay, so we have the base of the exponent. We have the exponent itself, and then we have this, and this is the, I guess you can call it the product of the exponential. We could call it the product. When it's put inside of a logarithm, it's called the argument, but in this particular case, we can call it the product. It is the product of 5 times 5 times 5, okay? So there's 3 parts to this. And all we're going to do is, a logarithm is just another way of rearranging these parts of an exponential relationship. Logarithms rearrange these parts so that the answer to the problem is the exponent. And I'm going to show you what I mean. I can rewrite this as log base 5 of 125. Okay, what this is saying is a logarithm is an exponent. Okay, so we're going to say what exponent. When you see the word log, you're saying what exponent. What exponent on 5 will give you an answer of 125? Or it's saying 5 to what power is equal to 125? Well, if we look up here, we can see that 5 to the third power is equal to 125. So the logarithm of 5, the logarithm of base 5 of 125 is equal to 3, because 3 is the exponent on 5 that will give you 125. So another way to think about it is this number to this power is equal to this product. Okay, that's what a logarithm is. And we're going to talk a lot more about logarithms in probably next week. We're going to do a lot of interesting things with logarithms. But here's what I want to understand about logarithms today, is that logarithms are the inverse of exponential relationships. And so therefore, logarithms are used to cancel exponential bases in exponential formulas, in exponential equations. Okay. So let's look at one. Let me give you an example. So let's say that I have 5 to the x power is equal to 19. Okay. Now, you know what? Let's use a different example real quick. Instead of a 5, let's use a 2. Let's say 2 to the x power is equal to, let's say, 128. Okay? So what this is saying is that 2 to some power is equal to 128. Well, we know that the answer to this is 7. Okay? That 2 to the 7th power is equal to 128. Well, I know that. You can grab a calculator and you can prove it to yourself. You can see 2 to the 7th power is equal to 128. So we know that the answer to this should be x equals 7. But what if we didn't already know this? What if we didn't know that x was equal to 7? Well, we can still algebraically determine this by canceling the 2. Now, what I have noticed is that many students, what they want to do is they think that this looks like multiplication to them. It looks like 2x equals 128, and therefore they want to divide by 2 and tell me that x is equal to 64, but this is wrong. Do not do that. That is not correct. We cannot cancel an exponential base. This is an exponential base. This is an exponent. This is an exponential base. We cannot cancel exponential bases through division. We can only cancel an exponential base using a logarithm. And so here's what we would do. Here's what we would do in this case. If I want to cancel this, I'm going to put it in parentheses, and I'm going to put log base 2 on the outside. And if I do log base 2 to one side, remember the rule of algebra is whatever you do to one side, you have to do to the other side. So I'm going to come over here and put parentheses around the other side, and I'm going to put log base 2. So if I do log base 2 to both sides, here's what's going to happen over here. Log base 2 of 2, watch this, does this. And I'm going to explain, by the way, I'm going to explain why this works next week. Okay, right now I want you to learn how to do it. Next week I'll explain why you can do it. Okay, log base 2 of 2. Well, what is log base 2 of 2? Well, based on what I just told you, this is saying 2 to some power is equal to 2. Well, 2 to what power equals 2? 2 to the first power, right? We know that 2 to the first power is equal to 2. So the answer to this, log base 2 of 2, is 1. And that basically cancels this 2. So log base 2 of 2 cancels the 2, leaving the x all by itself. And now we'll bring down the x, and we'll say x is equal to log base 2 of 128. Okay? And what this is basically saying is 2 to the x power is equal to 128, which is what we had written the first time. 2 to some power is equal to 128. What I'm trying to show you here, very simply, is that logarithms cancel exponential bases. Okay? But you have to do a logarithm of the same base. And so now, let's say that I have 1.75 to the 3x power, and let's say that's equal to 23. Let's say that this is equal to 23. So now, if I want to cancel 1.75, I'm going to do log base 1.75 on this side, and I'm going to do log base 1.75 on the other side. That's going to cancel the 1.75. It's going to bring down the 3x, and 3x is going to be equal to log base 1.75 of 23. Okay? And then, if I want to solve for x, I would divide by 3 and divide by 3. And now x is equal to log base 1.75 of 23 divided by 3. And that would be this. Now this, you may say, well, what is that? That you can plug into a calculator. And so now, well, how do we calculate this? Well, you learned in the last video how to calculate a logarithm. We're going to do, so log base 1.75 of 23, okay, is equal to log, hit the log button, key in 23, divided by log, parenthesis, 1.75, and then whatever answer you get to that, you're going to divide that by 3, and that'll be your answer. In fact, all right, so I'm going to hit log 23, close parenthesis, divided by log 1.75, close parenthesis, press enter, and then I'm going to divide that by 3, enter, and I get 1.8676. So here, x is equal, let's see, x is equal to this. All right, well, actually, that's not true. X is equal to 1.8676, and that is our solution for x. Okay? All right, let's do another one. Why don't you try this one on your own? What if I tell you that 1.0932 to the 12x power is equal to 2.5. Why don't you go ahead and pause the video and solve for x? All right, so let's see. We're not going to divide by 1.0932 because this is an exponential base. Okay? So what we're going to do is we're going to do log base 1.0932 to this side, and we're going to do log base 1.0932 to this side. Over here, this is going to cancel, and we're going to bring down 12x. And that's going to be equal to log base 1.0932 of 2.5. Okay? And now we're going to divide by 12 on both sides, divided by 12. And so x is equal to this. Well, how do I do this in the calculator? Well, to do this in the calculator, we do log of 2.5, close parenthesis, divided by log of 1.0932, press enter, and then divide by 12. So let's do this. Log of 2.5 divided by log of 1.0932. Press enter, and I get 10.28. Now I'm going to divide by 12, and I get x is equal to 0.8569. There we go. And that's my answer for x. All right. Let's do another one. Now I'm going to introduce you to how to cancel an exponential base of e. This one's actually really easy. We don't have to do anything too terribly nasty. This one's very, very simple. Let's say that I have e to the 0.14x power, and let's say that that's equal to, that equals 20. Make it something simple. That equals 20. All right, and let's say solve for x. Well, e is the same thing as, here watch, or a base of e means log base e, right? So here I would do log, because e is just a number, right? So I would do log base e and log base e on this side to be able to cancel the e, correct? So log base e here would cancel the e, you know, bam, and bring down the 0.14x equals log base e of 20. But I want to stop here, because here's the thing. The calculator actually has a special button for log base e. The special button for log base e says ln. Log base e is the same thing as ln. So instead of doing log base e of e, we would do ln of e. So ln cancels an e like this. Let me show you. If we got e to the power of 0.14x, if we want to cancel the e, we put an ln here and we put an ln here. That'll cancel the e, bring down the 0.14x equals the and ln stands for natural log, natural logarithm. Ln means the natural logarithm. Or, for short, we just call it the natural log. All right, so natural log of 20, that's ln, and we'll put parentheses 20. And then we would divide by 0.14, cancel, divide by 0.14, and x is equal to the natural log of 20 divided by 0.14. Well, there's a special button on the calculator that says ln. You've already been hitting it for a while. It's right there, ln. So now all we have to do is hit ln of 20 and then press enter. That's really easy. It's a lot easier to do in other logarithms, right? Then we're going to divide by 0.14, and we get x equals 21.2 398. There we go. So we just solved an exponential equation that involves an e. Let's do one more of these, and then I think we're going to be in pretty good shape. Okay? So let's say that we have e to the negative 0.26 x power is equal to 1.3. All right? Why don't you pause the video and see if you can figure this one out on your own. All right? So how are we going to cancel this exponential base? We can't get to this exponent. We want to cancel the exponential base. So we put ln here. That cancels. We put ln here, ln of 1.3. This comes down. Negative 0.26x is equal to the natural log of 1.3. Then we're going to divide by negative 0.26. Cancel. Divide by negative 0.26. And x is equal to the natural log of 1.3. So here we go. We're going to hit the natural log of 1.3. Close it. Press enter. And then we're going to divide by negative 0.26. And then we get negative 1.009. X is equal to negative 1.009. Okay? What I'm trying to show you here is that you can have a negative exponent and it still gets treated the same way. And you can also have negative answers and they work the same way also. Okay? So let's see here. So anyway, that's basically how you cancel exponential bases by using logarithms. So if you know how to calculate logarithms, and if you know how to cancel a logarithmic base, then you can solve all kinds of interesting equations. And that's what we're going to do in the next couple of videos. Is I'm going to show you how to solve for other variables in one of the four exponential equations that we have been working with. Okay? All right, well that's it for this, and I will see you in the next video.